Let's talk about common roots of quadratic polynomials. So let's say you started out with two quadratic polynomials, ax squared plus bx plus c, and let the other one be px squared plus qx plus r. And what we say is that both of these polynomials have a single common root. So let's say that if you made both of these being equal to 0, then let's say that x equals alpha satisfies both of these equations. Now, what relation can you form between the coefficients given here? This rather turns into very beautiful problems that you can get in some tests, particularly competitive ones. But anyways, the mathematics is just beautiful. So let's try approaching this problem. So what we're given with is the fact that x equals alpha satisfies both of these equations. Now, instead of focusing on what's not given, let's just try putting the given fact and seeing whether we can get something out of it. So what this means is that a alpha squared plus b alpha plus c is equal to 0. This is true. And the second one is that p alpha squared plus q alpha plus r is equal to 0. Both of these hold true. Now, a way to proceed from here might be something that you have already done while solving linear equations in two variables. Namely, what you can do is let's take x squared to be equal to some quantity, let's say alpha squared, not x squared. So alpha squared, let's say that is equal to, I don't know, let's take it t, and alpha without the square, let's take it to be s. And now you could have just put it right here, and that would have given you an equation, two equations in two variables t and s that you can easily solve. So let's try doing that. So at plus bs plus c is equal to 0, and pt plus qs plus r is equal to 0. Now, how do you solve it? Then my intention of doing all of this, my intention of solving this equation, is that since we know that s squared is alpha squared and alpha squared is equal to t, so we know that s squared is equal to t. So if you figure out a value for s and you figure out a value for t, you can put it in this identity and you would get a relation. So let's try that. Now, generally in problems like this, you can obviously do all the standard forms. You could have done elimination, you can do substitution. A way that's sort of preferred in the books and sort of makes our lives easier is cross multiplication. Now you can always try elimination on this and you would get like some answer for t, some answer for s. The de facto way books have done this is using cross multiplication. What I like to do is let's do it the more unconventional way, sort of the way our brain comprehends it better. So let's try solving it using elimination. So what we do is we multiply this first equation by p, so pat pbs plus pc is equal to 0. And let's multiply the second equation, this by the way is the second equation, with negative a, so negative ap, negative aq, and negative ar. Now if you went and added both of these, so this would have given you pb minus aq times s plus pc minus ar. This is equal to 0. This simply gives you that s is equal to ar minus pc divided by pb minus aq, and perhaps everything's correct. And once you have done this, you would just put this back in, and then you would get your value of t. The math sort of is a bit messy, and that's why the books usually ignore this method. If you went on and tried the cross multiplication way, let's just also do that. So we had this original equation, so the two equations, let me just remove the multiplication signs. So these were there. Now in cross multiplication, let's just cover the t part first, and let's just look at the other coefficients. So you would write t over, so br minus cq, is equal to, and now you cover the s part. So now you would cover this part, and here you write negative s. This is, by the way, something that comes out of solving linear equations in two variables. And then you do ar times pc, minus pc, so ar minus pc. This is equal to 1 over, and now you just ignore the constant terms and you cross multiply the other coefficients. So this part gets ignored. So aq minus bp, aq minus bp. Now this is rather easy now. So from this you can take this first quantity and the third one, and you can write that t is equal to br minus cq over aq minus bp first. And using these two things, you can write that s is equal to, notice there is a negative sign, so you'll have to compensate for that. So ar minus pc would become pc minus ar divided by aq minus bp. The math still is a bit messy. And now what we do is we plug it in right here. So s squared is equal to t. So that gives us pc minus ar squared divided by aq minus bp. This is equal to t, but t is br minus cq divided by aq minus bp. There is a squared there as well, by the way. And just to even things out a bit, you just write pc minus ar squared. You multiply both sides by this entire denominator. So this gives you pc minus ar whole squared is equal to br minus cq times aq minus bp. And I solved this as a math problem. You are really not expected to memorize this result, this relation between the coefficients. What's more interesting is the way how we arrived at it. So what perhaps you would like to consider to remember is that we can simplify quadratic things into linear equations in two variables, perhaps two or more variables, as you think about it. And you can actually solve them. You can figure out a constraint. In this case, the constraint was that s squared is equal to t, and write equations for it. You might get some different scenario, but the idea still remains the same. Now, this is when one of the roots of these equations are same. So, for example, would be, let's take x squared minus 3x plus 2 and x squared minus 4x plus 3. If you factorize it, both of these come out to have x minus 1 as their common factor. This would be x minus 1 times x minus 2. This one would have x minus 1 times x minus 3. And 1 is the common root of both of these. What about if alpha and beta? Let me do that differently. So let's say that you again had these two equations. Let's say you had ax squared plus bx plus c is equal to 0. And you also had px squared plus qx plus r is equal to 0. And you said that alpha and beta are roots of both of these, are common roots. Now, in this case, you might be tempted to go for the computational part, but what's really interesting right here is that a quadratic is actually determined by its roots, by two of its roots, and in this case, both of them are common. So if you just took ax squared plus bx plus c, you could have written this in the form of x minus alpha times x minus beta times a. This is something that we know about quadratic equations, simply because putting alpha or beta here would just make this thing equal to 0, and there is a coefficient of a, so there is a coefficient of a here as well. This second polynomial would have become p times x minus alpha times x minus beta is equal to 0. And if you look at both of these carefully, what this just means for you is that both of these equations are identical. And so what that means is that p is nothing but some sort of multiple of a. So p is equal to a k. Let's take some multiple k. If you say it in that way, then you can also derive, and I'll just leave this as an exercise, that q, the second x coefficient, is equal to the same k times b, so bk, and you will also have r equals that same thing k times c. And this makes sense. This entire equation is just a multiple of the first one, or you could have done, let's say, the other way. If this is double the first polynomial, then this will be half that polynomial. And from this, there's a really nice condition that you can figure out of this, that if both of these equations have two common roots, that is, they're just same, then you can always write that p over q is equal to q over b is equal to r over c. So basically, these coefficients are actually proportional. And this is relatively straightforward. You don't have to memorize anything of what we have talked about here. The main idea is that you recognize when you need to use which method to, let's say, approach a problem, or let's say understand the beauty of that mathematical idea. See you in the next videos.